Hello students, now we are going to start the topic rocket propulsion from the chapter Laws of Motion of class 11th Physics. Now let's begin this chapter. With the first topic, rocket propulsion. So rocket propulsion is based on the law of conservation of a linear momentum, or we can say that Newton's third law of motion. Now what is the Newton's third law of motion? To every action, there is always equal and opposite reaction. So by this principle, the rocket propulsion, this topic and this thing works. In detail, what we can say that the force that is used by the rocket to take off from the ground and into the atmosphere that force takes some time, and we know force into time is what? Momentum. And this conservation of momentum, also known as third law of motion. So during this process, the third law of motion applies for rocket propulsion. Here, the fuel is forcibly ejected from the exit such that an equal and opposite reactions occur. So as I told you in the previous video that Newton's third law applicable for two different bodies or two different things. So first thing here is the fuel and second thing is rocket. So when this fuel is burned, rocket start to move in the upward direction. Clear? This is a basic concept which we will apply here. Correspondingly, we will make the diagrams and other things like types of propulsion we will see. So second thing we can say rocket is a system in which mass varies with time. Suppose u naught be the initial velocity, I'm just taking as a u, of the rocket. Initial mass is m naught with the fuel at any time. In the second scenario, as I told you, with respect to time, mass varies. So mass changes after a certain interval of time. So rate of mass of gas is ejected. We can say R is equals to dm by dt. What is R here? Rate of mass of gas ejected. Mass at any time t, that m is equals to m naught minus RT. How this factor came? So this is came by integration, simple, like R is equals to dm by dt. So we can write like R dt is equals to dm. T from 0 to t, R dt. And mass varies from m naught to m, dm. We know after integration we get this RT from 0 to t is equals to mass m from lower limit will be m naught to m. After solution, we get RT is equals to m minus m naught. Clear? What I did, I'll just transfer this m, okay, here. So m naught is equals to m minus RT. Okay. So what they taken, m1, this, m2, this we can take. Okay, this one m1, m2, m1. This will be again m1, this will be m2. So for change in mass, m2, that means m is equals to initial mass minus that rate with respect to time. I hope you will be understand like how this term will be came in the nature in detail. Third, acceleration of the rocket. So A is equals to u by m dm by dt. How this factor came? So we know acceleration is a nothing but the change in velocity with respect to time. So at particular time we can say du by dt. Okay, but here the change in velocity terms comes when the masses decreases. Clear? Mass can't be increased in this scenario because continuously fuel will be less. Okay, or we can say fuel will be exfoliated. So for that scenario, in the case of u, we just multiply and divide by the m. Same factor became in this form u dm by m dt. Now dm by dt gives the rate of mass of gas ejected. U naught is the initial velocity of the rocket and u is the velocity of ejected gas. Then the velocity of the rocket at any time v is equals to u plus u log base e m naught by m. This is a direct equation which we are using here. M naught is equals to m of the gas at any instant of a time t. Thrust on the rocket, thrust is the what? Force per unit area. Okay. So what is the difference between thrust and pressure? So force, pressure is in what pressure we are applying. The perpendicular force divided by any particular cross-section area. But here the force is actually not defines any particular direction. So in a particular direction, if I am defining, so that will be pressure. Random direction of a force with respect to area is defined as a thrust. So F is equals to ma. M in the place of A, dV by dt we can easily put. Now in the case of dV by dt, what we can write in the place of dV, u dm by dt. Finally the value comes Ru. So according to the acceleration, we know that A is equals to F by m. Force is equals to mass into acceleration. I think this is a basic concept which you all know. So A is equals to F by m came from there. I'll just put this value of F here. Now this value came in this final result like Ru by m. Velocity u log e m naught by m. So for the minimum rate of consumption, dm by dt is the minimum. Final result we can say mg by u. The effect of gravity is considered, then velocity v is equals to u log base e m naught by m minus gt. Acceleration we've calculated, which is earlier, a is equals to u by m dm by dt minus g. And thrust final, what we calculated, u dm by dt minus mg. Now these are some equations. Moving ahead, like rocket propulsion diagram. So if this is a rocket, clear? So dragging force continuously applying downward direction, gravity again try to attract the thing downward direction. But because of this fuel which is emerging out, some force is applied on the upward direction, matlab force per unit area, that is thrust, in the upward direction. So we can say this is simplified diagram of liquid fuel rocket and solid fuel rocket model. Okay. In liquid and in solid, there will be few things are changed, like the changement in the liquid oxidizer and solid oxidizer. This here, the few things are filled. In the case of a liquid, liquid oxidizer will be filled here, and in the case of a solid, solid oxidizer will be filled here. Here, the fuel is in the liquid. I'll just put all these things, liquid and solid propulsion. In the liquid, the fuel is in the form of liquid. Fuel is in the form of liquid. In gases, in solid, fuel is in the form of solid. Okay. Pump both side will be here, grid and landing, like legs will be both side will be same. Come in the liquid, there will be one chamber which will be combustion chamber will be here, and nothing will be more changes in this, like the chamber or oxidizer. As I told you, in liquid this will be liquid oxidizer, and here solid oxidizer we are using. These are some differences which may ask in your examination, students, just to take a screenshot. Moving ahead, in liquid fuel rocket, I can say liquid fuel rocket, a liquid fuel rocket such as liquid oxygen, liquid nitrogen, it have one oxidizer also, which is in liquid, as I told you earlier. Pump to carry the fuel and oxidizer, to carry the fuel and oxidizer. A combustion chamber a combustion chamber where the two liquid mixed and burned. A hot exhaust coke, exit from where exhaust is removed. Okay, so in solid fuel rocket, what is the difference in between? In solid fuel rocket, red one is a, like I'm just representing for the solid fuel oxidizer mixer with the cylindrical hole. So it will, in solid fuel rocket, like oxidizer mixer with a cylindrical hole. Cylindrical hole. In the middle, ammonium nitrate, ammonium nitrate, and ammonium dinitramide, okay, is filled. An igniter to combust the propellant surface. So exit where the exhaust is removed. Types of rocket propulsion, as I told you. In types of rocket propulsion, so we have basically three. Okay, one or more we can add it like a liquid. First one is a liquid, fuel, chemical propulsion. Second, that solid fuel, chemical propulsion. Third is a cold gas, fuel chemical propulsion or cold gas chemical propulsion. And the last one is iron. Now, if I'm talking about the factors which are factors affecting rocket acceleration, these are the acceleration will be greater, okay, when exhaust velocity VE greater. So acceleration will be greater if, okay, exhaust greater, so acceleration is greater. And when acceleration is greater, we can say fuel rocket burn faster. Fuel, it's a simple thing that when velocity more, acceleration more. And when acceleration more, fuel rocket burn, okay, rapidly or faster. As mass of the rocket decreases, acceleration, okay, will be increases. Mass decreases, acceleration increases, because we know F is equals to ma, a is equals to F by m. So if mass is less, acceleration is more. So as much as mass is less, acceleration will be start. Now moving on the multiple choice question. The first question is, the propulsion of a rocket is based on the principle of law of conservation of. We have an option linear momentum, velocity, angular momentum, mass. The correct answer for this question is linear momentum. Next question is, a 500 kg rocket is set for a vertical firing. The exhaust speed is 800 meter per second to give an upward acceleration of 20 meter per second. The amount of gas ejected per second to supply the needed thrust is. Here is the options. The correct option is C. Student, this is your task. Okay. And I hope you understand the lecture. Take care everyone, and if you have any doubt, so you may ask in the comment section. Thank you everyone for watching this video.